DeepSeek became famous by proving that powerful AI models did not always need Silicon Valley-sized budgets. Now it is moving from chatbots into machines that can walk. The Chinese AI startup has invested 140.8 million yuan, about $20.8 million, in humanoid robot maker Unitree as part of Unitree's Shanghai IPO. The investment gives DeepSeek a stake in the company, but the more important part is the strategic partnership behind it. DeepSeek will bring the AI models. Unitree will bring the bodies. Together, they want to attack one of the hardest problems in artificial intelligence, teaching a machine not only to understand instructions but to turn those instructions into reliable physical actions. This is called embodied intelligence, and it could become the next major battleground between China and the United States. Modern language models are already good at manipulating information. They can write software, solve mathematical problems, summarize documents, and reason through complicated instructions. But ask an AI system to enter an unfamiliar kitchen, identify a cup, open a cabinet, pick up the cup without breaking it, fill it with water, and place it on a table, and the problem becomes much harder. The model must understand language. It must see the environment. It must estimate distance. It must identify objects. It must plan a sequence of movements. It must control dozens of motors. And it must continuously correct itself when reality does not behave exactly as expected. DeepSeek is strong at the first part. Unitree is strong at the second. That explains why the partnership is more interesting than the $20.8 million investment itself. Unitree has become one of China's most visible robotics companies. Its humanoids can walk, run, dance, perform martial arts routines, and recover from disturbances. Its quadruped robots have also been sold for research, education, inspection, and other applications. The company's business is growing quickly. Unitree generated roughly 1.7 billion yuan in revenue in 2025, more than 4 times the previous year. Humanoid robots produced about 867.8 million yuan of that revenue, overtaking four-legged robots as the company's largest business. Its Shanghai IPO values the company at roughly $9 billion and makes Unitree the first mainland-listed Chinese humanoid robot manufacturer. But impressive motion is not the same thing as useful autonomy. A robot can perform a choreographed dance because engineers know exactly what movement should happen next. A factory worker does something fundamentally different. The worker looks at an environment that may change every minute, understands a goal, makes decisions, manipulates unpredictable objects, notices mistakes, and adjusts. That flexibility is the missing robot brain. Reuters reports that DeepSeek and Unitree plan to combine DeepSeek's model expertise with Unitree's mechanical engineering, motion control, and embodied intelligence work. The companies specifically identified the ability to understand unfamiliar environments and convert instructions into physical actions as a major bottleneck. This creates a potentially powerful feedback loop. Unitree can provide DeepSeek with something language model companies desperately need: physical world experience. Imagine training a chatbot. You can collect trillions of words from books, websites, software repositories, scientific papers, and conversations. Now imagine training a robot to fold a shirt. The internet contains videos of people folding clothes, but video alone does not reveal everything the robot needs. How much force should the fingers apply? Where exactly should the fabric be gripped? What happens when the shirt is rotated? How should the arm move if one sleeve is trapped underneath? What does failure look like? The most valuable data often comes from actual interaction. Chinese robotics companies are already operating data collection facilities where people guide humanoid robots through repeated physical tasks such as opening doors and folding clothes. Those demonstrations can record camera images, joint positions, forces, hand movements, and successful or failed actions. This is the physical equivalent of training data for a language model. And it may become one of the most valuable datasets in the AI industry. DeepSeek could potentially use Unitree's robots as a distributed system for collecting real-world experience. Unitree could then use improved DeepSeek models to make those robots more autonomous. Better robots generate better data. Better data produces better models. Better models make the next generation of robots more useful. That loop is similar to the advantage autonomous driving companies have pursued for years. A self-driving company with millions of vehicles can collect rare road situations that a laboratory cannot easily simulate. Humanoid robotics could develop in the same direction. The company with the largest fleet may eventually have the largest physical world dataset. Unitree is already trying to scale the hardware side of that equation. Its IPO will provide billions of yuan for robot development, embodied AI models, new products, and manufacturing capacity. The company reported nearly 1.7 billion yuan in 2025 revenue and has been rapidly expanding humanoid shipments. DeepSeek brings a different advantage. Its reputation was built around making large AI models more computationally efficient. Earlier, DeepSeek systems used mixture of experts architectures that activate only part of the full network for each token. That allows a model to contain a large amount of knowledge while reducing the computation required for each response. DeepSeek has also developed techniques for reducing memory use and inference cost. Those ideas could become extremely important in robotics. A humanoid cannot carry a data center on its back. It has limited battery power, limited cooling, limited onboard computing, and strict weight constraints. Sending every decision to a remote cloud server creates another problem: delay. If a robot detects that it is falling, it cannot wait for an internet request to travel to a data center, run through a giant model, and return an answer. Some decisions must happen locally. This creates a hierarchy of intelligence. Fast motor control can run directly on the robot. A smaller vision or action model can handle immediate decisions. A larger model can perform high-level reasoning or planning. Cloud systems can handle tasks that are less sensitive to delay. DeepSeek's obsession with efficiency could make it well-suited to this architecture. But there is an important limitation. DeepSeek's strongest commercial models have mainly focused on language, coding, mathematics, and reasoning. Reuters notes that the company has released separate vision language research models, but multimodal perception has not been integrated into its flagship commercial system in the same way as some competitors. A robot cannot live on language alone. It needs to understand video, depth, touch, sound, motion, and spatial relationships. It must learn that an object continues to exist when it moves behind another object. It needs a physical understanding of gravity, friction, weight, and momentum. Some of this knowledge can be learned from data. Some may need simulation. And some can only be learned by interacting with the real world. That is why Unitree matters to DeepSeek. The partnership gives the AI company a path beyond the screen. For Unitree, the advantage moves in the opposite direction. Robot hardware is increasingly becoming competitive. China already has numerous companies producing humanoids, including Unitree, UBTECH, Augibot, and others. Motors are improving. Actuators are becoming cheaper. Batteries are getting better. Manufacturing is scaling. But hardware alone can become commoditized. Two robots may have similar arms, legs, cameras, and joint structures. The one with better intelligence could perform far more valuable work. This creates a comparison with smartphones. Eventually, smartphone manufacturers could all buy high-quality screens, cameras, memory, and processors. The competitive difference increasingly came from software ecosystems, operating systems, AI capabilities, and integration. Humanoid robots may follow the same pattern. The physical machine becomes the platform. The AI becomes the product. This helps explain why Unitree itself has described intelligent models as central to future development. Its robots already demonstrate impressive balance and motion, yet reliable autonomous work remains much harder. And this is also where the competition becomes global. Tesla is developing Optimus. Google DeepMind is creating Gemini robotics models capable of connecting language, vision, planning, manipulation, and whole body movement. NVIDIA is building its GR00T robotics platform and simulation infrastructure. Figure is developing its own humanoid systems. Aptronic is working with major AI companies and industrial partners. China is approaching the same problem with a different advantage: manufacturing scale. The country already dominates many parts of the electronics, battery, motor, and industrial supply chains required to build robots cheaply. If Chinese companies can combine that manufacturing base with increasingly competitive AI models, humanoid robots could follow a path similar to electric vehicles. At first, the race is about technical capability. Then it becomes about manufacturing cost. Then production scale. Then price. DeepSeek and Unitree fit directly into that strategy. DeepSeek has already competed by dramatically reducing the cost of AI inference. Unitree has built a reputation around relatively affordable robotic hardware. Combine the two, and the objective becomes clear. Build useful physical AI at a price that allows it to scale. But the word useful is critical. The humanoid industry remains filled with demonstrations that look far more impressive than actual productivity. A robot performing martial arts for 2 minutes does not prove it can work 8 hours in a warehouse. A robot folding one shirt does not prove it can fold 10,000 different garments without human help. Real workplaces contain dust, damaged objects, unexpected people, changing lighting, network failures, slippery floors, unusual packaging, and equipment that was never designed for robots. Reliability must move from 90% towards something much closer to 100%. A worker who fails one task in every 10 would be unacceptable in many environments. Robotics exposes AI errors in a way chatbots do not. A hallucinated sentence may be annoying. A hallucinated physical action can break equipment. Safety therefore becomes part of intelligence. DeepSeek and Unitree will need systems capable of understanding not only what can be done, but what should not be done. And the financial pressure is already visible. Although Unitree's revenue continued growing in early 2026, its profit excluding one-off items fell 52.6% in the first quarter as research and marketing expenses increased. Building humanoid robots at scale is expensive. The company must invest simultaneously in hardware, manufacturing, software, data collection, and distribution. DeepSeek's investment does not solve those problems. But strategically, it joins two pieces of the Chinese technology ecosystem that previously developed largely in parallel. One company built inexpensive intelligence. The other built inexpensive bodies. Now they want the models and machines to learn from each other. The $20.8 million investment is small compared with the billions being spent on AI data centers. Its significance is not the amount. It is the direction. DeepSeek is beginning to move from digital intelligence toward physical intelligence. Unitree is beginning to move from impressive motion toward more autonomous reasoning. If the partnership works, the result will not simply be a robot running a chatbot. It could be a system trained from the beginning to see, reason, move, fail, learn, and try again inside the physical world. That is the real promise of embodied AI. The previous AI revolution gave machines language. The next one may give that language hands and legs.